Hi everyone. Today I will present to you our project about purchase decision of medical equipment for local hospital. These are the devices we are made decision for purchasing for the hospital, for the local hospital. First one is the electrocardiography, defibrillator, electrosurgical unit, hemodialysis machine, ICU ventilator, anesthesia machine. So this is the project for EE471 course, starting from electrocardiography. So the electrocardiography or ECG is used to measure the electricity that comes from the heart, specifically from SA and AV nodes. The device is used to monitor heart activity. The outcomes are presented in a graph with voltage on y-axis and time on x-axis. Through the graph, the doctors can diagnose the patient's heart activities. So the most important features needed for electrocardiography device in the hospital. The first one is the defibrillator overload protections. So we can make sure that the device can have protection from defibrillator shock. The second one, the power requirements is 220 volt. So all the plug in the room use 220 volts in the hospital. The battery operation for if there electricity cut in the hospital, so the device can uh, working without stop. And 2-year warranty from the company and service contract. In the tender document with the technical specification required, we listed the previous specifications with and detailed in this schedule. So in the first one, the defibrillator overload protections for protecting the device during the defibrillator, and the power requirements 220 volt available in the hospital room. Battery operation, keep the device working during power outage. 2-year warranty for warranty the device from the company, and service contract for the device maintenance. So we have here three company. These three companies, we made a decision for which one is better to purchase. So we end up with the second one. Actually, in the first one and the third one, in the first one, ALMED doesn't have a 2-year warranty, so this is minus 1 point. And in the third one, the company doesn't support the device with 220 volts and no 2-year warranty for the device. So the second one chose to be the best the device for the hospital, and the 1 and 2 used to be the backup devices.
Assalamu alaikum warahmatullahi wabarakatuh. I am Hassan Sahra. For the purchase decision of medical equipment, I will talk about defibrillator. The defibrillator device gives an electric shock to remove the serious heart disorders such as ventricular fibrillation and restore the heart to a normal rhythm. To avoid the sudden cardiac arrest that may lead to death. It always the largest number of people to deal with the emergency medical cases that require electric shocks because the device is portable and easy to use, and it can be used by non-specialists. Important features needed for the hospital. Simple, the module automatically turns on, which is clear and obvious within off-on buttons. Intelligent, sensors assess and correctly advise that a shock should be delivered at the appropriate time, personalized to every man, woman, or child based on body type. The device designed for adult defibrillation should have energy setting of 50 to 360 joule. The response or the reactive, the device can quickly distinguish when the user has completed a step and is ready for the next instruction. High capacity and long life battery should be. The unit should be able to charge to maximum energy in a short time. The patient's heart rhythm is analyzed in seconds. The defibrillator's ECG input amplifiers should be protected against damage from defibrillator energy. The display should recover a readable ECG graph within 5 seconds of an input overload from a maximum energy defibrillator pulse. Automatically analyzes the heart rhythm to determine whether a shock is required. Automated self-test that tests the device circuit and software connection to AC power, electrodes, batteries, and discharge capabilities. Pacemaker cables should be at least 1.5 long to allow convenient positioning in various patients' locations. Price and warranty needed to be considered as well. Facilities should look for the best offer of manufacturers. These are the three alternatives types of defibrillator: GE Medical Responder, Philips Healthcare Heart Start, Physiocontrol Life Pack. This is our tender document. The specifications required, such as FDA clearance, energy range, the instructions, type of display, screen, automation, ECG recorder, self-test, type of battery and the life of battery, the weight of the device, the price and warranty. Based on the comparisons, we choose Philips Healthcare Heart Start to our hospital, and the other two options are backup. Thank you for listening.
السلام عليكم ورحمة الله وبركاته. I am Ryan Khalid Al-Mash'abi and I am a student at King Abdulaziz University and a member of the Department of Medical Engineering in our hospital. Because of the urgent need in our hospital for the presence of electrosurgical unit, the head of the department assigned me the task of studying the need and determining the appropriate model for the hospital. The study consists of several stages. The first stage is determining the most appropriate type for use in the hospital. Second stage is write a list of the required specification for the device and present it as a tender to the suppliers of medical devices. The third stage is studying the offers submitted by suppliers and determining the best three of them. The first stage, determining the most appropriate type for use in the hospital. The electrosurgical unit should have a solid-state generator, a typical frequency range of 0.3 to 1 megahertz, and it should have an isolated monopolar output and a hand switch and a foot switch and a bipolar output. The maximum output power for monopolar cutting should be 300 watts with a tolerance of 10%, and the maximum open circuit voltage should be 2 kilovolt peak to peak with tolerance of 10%. For general purpose of operating room use. The maximum output and open circuit voltage for coagulation should be 120 watt with tolerance of 10% and 6,000 volt peak to peak with tolerance of 5% respectively. Bipolar mode should use a maximum of 50 watt with tolerance 10% and 300 volt peak to peak with tolerance 10%. The unit should have a dispersive electrode contact quality monitor, an independent output, visual and audible activation indicators, and an alarm capable of volumes. It should have a power setting display and convection or fan cooling system. The unit should include an alarm capable of volumes. The budget allocated to purchase the device is $10,000 as a maximum. The second stage is write a list of the required specifications for the device and present it as a tender to the suppliers of medical devices. This list was built on several considerations, including generator type, frequency, output of monopolar and bipolar, availability of hand switch and foot switch, input voltage or of modes, monopolar and bipolar, protective circuits, self-test mode, independent output, activation indicators, whether visual or audible or volume control or defeatable inaudible, also power setting displayed and calling and power requirement, the price, the warranty, training, support after purchase, availability of additional accessories, operating cost, environmental considerations. Each item has a value so that the offers submitted by suppliers can be compared and the decision taken using a scientific and impartial methodology. The third stage, studying the offers submitted by suppliers and determining the best three offers. After studying the offers submitted, the opinion was still that the best device and which meets the needs of the hospital from a technical and financial point of view, and the aspects that were considered are: first one is Beijing Billion Electronic DGD 300 series, and the alternatives are, if it is not available, Elmed electrosurgical unit 300 M-M, then Cameron Miller 2500, and the picture the score of each of them. Thank you for listening.
Assalamu alaikum, my name is Asam Abdullah. And I will continue now my reading on RS speed. Of course, the project aims to search for 3 different devices and select the best one according to our requirement. In the beginning, we have an assumption that the cardiovascular disease department will have a capacity about 20 bed, and the respiratory disease will have a capacity about 30 bed, and the last thing, the department of kidney problem will have a capacity about 20 bed. Here is some feature for our device. We want our device to be about disinfection. We want our device to be able to deal with the chemical. We want to sterilize it with chemical. And we want the weight of the device to be less than 130 kg. And the cost, we put the maximum cost around $40,000. Of course, we want a warranty for the device at least 1 year. For temperature range, we want to control the material about up to 41 or less. For a pressure range, we are looking for a device that have pressure range between -500 up to 850. And for a blood flow, we are looking at device between 300 up to 700. For a filter flow, we are looking for a device between 100 and 800. Here we have 3 option devices. First one is the Icu 2000 plus, and the second one is the now Dialog plus, and the last one is the Series 2018. For a comparison between all the solutions, we have to set some point for each option. Of course, there is a lot of specification for all the devices, but we focus on the specification that we identified before. 0 means that device have no advantage at all. 2 is meaning that the device have advantage at 1 between 0 and 2. So after evaluating all the devices, we have come up with the next table. The first device have 16 points, the second device has 16 points also, and the third device have 18 points. To decide what device we will choose for our hospital, we found 3 options and we evaluate all the solutions according to our requirement. But we assume that the first device have a price equal to $37,000, and according to the evaluation we will choose the third option. And now my teammate inshallah will continue with you.
Assalamu alaikum warahmatullahi wabarakatuh. This is Abdulaziz Batawi, student of Biomedical Engineering Department. Today, inshallah, I'll be talking about the ICU ventilator. Today we're gonna cover a little bit of the theory or the mechanism of how does ventilators work, and then we're gonna go into explaining what or which it's important for us during monitoring this kind of process. So hopefully, inshallah, you will learn today. The definition of ventilator. So what is a ventilator? Usually it is known as a term of cleaning or filtering air passages So when I say a ventilated room, that it's provided with a cleared or kind of airways filtered from bacteria, dust, any small particles. But then when I say a medical device, an ICU ventilator, here I'm specifying something, which is an instrument or a device that supports the respiratory system in the human body, either by pressure, flow cytometry. It has many different applications, but mainly they use airway pressure. As you can see, there is an exhale time and inhale time, and during that there is also a fact of exchanging the O2 and the CO2 in the alveola, as represented in the picture. So during that, everything should be maintained, calculated, and precise in order to make this function safe, where it doesn't affect the heart rate, for example. As we all know that each system in our body is connected to the other one. So if one has a failure, catastrophic diseases could affect others. So here are the parameters on a monitor, which we usually see on a simple ventilator, or actually state-of-art ventilators. So this is the monitor I choose based on the comparison I was given, and it's the Hamilton G5 series screen. So we could see the peak airway pressure. It represents the total pressure of air applied to lungs and alveoli, and basically the whole respiratory subsystem interactions. And then we have the minute ventilation, or minute, so it calls the total amount of time for the respiratory to happen, and the gas consumed during that. And then we have the end of tidal volume. Okay, so this represents the amount of returned gases to the ventilator itself. So usually it's like sending a pulse during ventilation, so it's support or control or deliver, right? So based on the feedback or the returned amount of the volume of the gas itself, we can carry on or conduct to control this closed system. So it's like working as a feedback to the system. And then we have this kind of physical representation of what is applied or what is happening during the ventilation. So as you can see, this is the normal lungs. Then we can see the air applied to it, so it helps in the inhalation or exhalation process. And also, as I mentioned before, it affects other system bodies such as the heart rate. So we can see that the blood saturations, the SpO2 level could be calculated or monitored during this process as well. Then finally, we have the modes for the ventilator itself. As we can know, sometimes the ventilator itself take over control, where there is no response, or there is a weak response to actually no response, zero response, or involuntary work. So when that happens, the controlled breath work and the ventilator does all the work. So in some other cases, in the assisted breathe, so it gives a small peak or indication of breathing, and then the ventilator itself work as an amplifier which support that signal or that mechanical trigger. Then we have the supported. So at the supported it happens where the patient itself can breathe but on a weak phases. So it's like a secondary backup for it, for the breathing mechanism, in order to have a safe respiratory. And here we have the oxygen level, as mentioned before. We have the respiratory rate as well, so number of breath per minute. And here we have the parameters that shows what kind of consumables are using the ventilator itself, and what is desired and what is the actual value of it. That's all. I hope you enjoyed the video.
Assalamu alaikum. My name is Ala Al-Melawi, and today I am going to talking about anesthesia machine. Anesthesia units dispense with mixtures of gases and vapors and vary the control the patient's level of consciousness or analgesia during surgical procedures. Anesthesia units primarily perform the following four functions. First of all, providing the patients with oxygen, mixed gas mixtures in addition to O2, which may contain vapor, anesthetic, nitrous oxide, other medicinal gases, and air. Facility spontaneous or controlled ventilation, or with the help of these gas mixtures, reducing, if not eliminating, anesthesia-related risk to the patient and the clinical staff. Most important features needed for the hospital for anesthesia machine. O2 system fail-safe, hypoxic mixtures and gas cylinder, oxygen if central supply fails, internal battery for units equipped with automatic ventilators capable of operating the units of at least 30 minutes, power required 110, 125, 220, 250. The units must be able to measure oxygen concentration, airway pressure, and either the volume of expired gas or the concentration of expired carbon dioxide. The units should have power loss alarm, and the backup battery should have automatic low battery alarm. The low battery alarm should visually and audibly indicate when the battery voltage drops below a unit level. Some anesthesia units require standalone physiological monitors or anesthetic agent monitors. Patient type for all patients. A tender document with the technical specification required that you offer to vendors. This schedule shows the specifications required to the anesthesia machine and details. O2 system fail-safe, hypoxic mixer and gas cylinder oxygen central supply fails. This details 30% O2. Internal battery capable of operating at least 30 minutes. Power required is the best 220, 250. The units must be to measure some parameters like like concentration, airway pressure, and either the volume of expired gas or the concentration of expired carbon dioxide. Alarm: the units should have power loss alarm, and the backup battery should have automatic low battery alarm. The alarm should be visually and audibly. The low battery alarm should visually and audibly indicate when the battery voltage drops below a unit level. Some anesthesia units require standalone physiological monitors or anesthetic agent monitors. For example, ECG. Patient age, we have for all. We want to make anesthesia machine for all patients. This is schedule. We take the ECRI Institute device comparison, and based in comparison we put specification here, and we choose three company: Acuma Pro Eng, Vacoma Vigor, and Animedic Valcon. And after we make a comparison, the best company is Acoma Vigor 2, because it's it have most of our specifications here. The percentage is 62.5. As we saw, as with the comparison, Acoma Vigor is the best company, and Acoma Pro Eng and Animedic Valcon C are the backup companies.